All right, once again, good afternoon, and thank you for taking the time to come. So on behalf of the Shardus team, I'd like to welcome you for the Q2 update of the Shardus team. Obviously, the purpose of this meetups is multifold. You know, there's a few reasons why we do these quarterly updates. One, to make ourselves accountable. Every quarter we do these updates, and in order for us to be accountable, what we do is we present our commitment for the next quarter. And at the end of the quarter, we come back, we show the progress that we have made. And if we've met our commitments, or if we have missed our commitments, and by what, if we do. For our goal has always been to meet the commitments. That's one reason why we do so. We also like to do the demo the process, demo the progress to show where we are and whatnot. Most importantly, this technology being a new technology, we like to bring the awareness to this project, this new technology called the blockchain. By now, I'm sure you all are aware of it or heard of it at least one way or the other, or at least heard of Bitcoin. But just the small piece of the puzzle. There's a lot there in the technology to offer, and that's what Shardus is going to demonstrate this. Now, last year, every quarter, we kind of start off with the introduction video, but this time it's already on the website, so we're going to kind of skip that one. But what I want to do is next, I want to introduce you to the man behind the project. Most of you have met him. I've known him for many years. He's the guy who's behind this project, and his experience speaks for it all. His experience in the technology industry has been with NASA, Zynga, Yahoo, and he has been the brains behind some of the early ideas, in the 1990s, where he built the matrimonial system, the real estate system, and the Arima game, and all that. So this is the guy who's behind this technology. So his name is Omar Syed. Without further ado, I'd like for him to come and take over the presentation. Omar.
All right. Thank you very much, Smir. Thank you guys all for coming out. This is not just an update of what we're doing, but also it's a good opportunity for everybody to get together once a quarter, like a meetup and network. And, we're starting to see that we're bringing together a lot of the people in the Dallas area that are interested in blockchain and cryptocurrencies. So, keep that in mind, and, it's a good opportunity. And we'll be doing this again, next quarter and the quarter after that. So we still have at least another year to go in our overall roadmap. Thanks for coming out. And, basically to introduce you to, what we're doing here, Shardus is focusing on building what's referred to as sharding into blockchain. Now, this whole space of blockchain, it's really like a revolution that's going on. And, there's a quote that, there's nothing more powerful than an idea whose time has come. And I really think that this is one of those ideas that is really going to revolutionize a lot of things. So, it got started back in 2009 with the release of Bitcoin, and the focus was really on cryptocurrencies. People didn't even recognize the technology behind it, and then later on, in probably about 2013, people started recognizing that, the blockchain technology that's powering Bitcoin actually has a lot of value. And, so far, it's had the biggest impact on the financial sector. I mean, financial sector hadn't been disrupted for, I don't know, maybe hundreds of years probably. But, this technology is going to do that. But that's not the only place it's going to, get into. It's eventually going to have an impact on a lot of different sectors. And so, if you're involved with businesses, if you're, involved with consulting, you need to be aware of what's going on with blockchain and how it's going to impact your industry. Kind of like being oblivious to it is kind of like being oblivious to the World Wide Web in the 1990s. So it's definitely something that, to keep an eye on. So to give you an idea about how Shardus fits into this space, so Shardus is building the software to allow creating decentralized networks which are a lot more scalable than what the current technology offers. Also, once the software is created, we intend to use that software to create our own payment network and a coin, which we refer to as Liberdis, and launch a network on that. And that serves two purposes. One, it shows, it showcases the Shardus technology that's being used underneath. And it also provides an avenue to support the continued development of Shardus. Now, why are we building this? Why did we just wake up and think that we need to build some better, blockchain technology? We actually had an idea for building a universal basic income-based stablecoin. This goes back to 2011, and using that in a social network that we refer to as Globalville. And I won't go into a lot of the details of that just to save on time, but if you go back and look at the first quarterly update video that's on our YouTube channel, you can learn a lot more about what we're doing there. So, why do we have to build something new? Why not just use something that's already out there? So the current solutions that are out there are not very scalable. A lot of times the word scalability gets used in the wrong way. Projects refer to themselves as more scalable than something else, when actually they mean that it's faster than something else. So, it's not the right way to use the word scalability. So, because adding more networks or adding more nodes to the network doesn't actually help it get faster. So that's one of the problems that we currently have. Also, the systems are not very decentralized. I mean, they start off kind of decentralized, but then tend towards becoming more and more centralized as, companies start to make mining like a business, and then they squeeze out a lot of the smaller guys, and so you end up with just, maybe 3 or 4 big mining companies that are, doing all the mining or staking, and regular people can't participate in that. So if you want to maintain decentralization, you have to give a lot of thought to how you design your network so that, it doesn't tend towards centralization. Also, the systems that we have out there are not very energy efficient, especially the well-known ones like Bitcoin. It's taking up so much energy now. It's I think it's equal to the same energy consumption as Switzerland. And it doesn't look like it's stopping anytime soon. I mean, as Bitcoin gets more popular, looks like the miners just keep throwing more money into mining equipment and, and putting out more hardware out there to do mining, and it's just continuing to suck up more and more energy. But, really in the long run, I don't know if that's going to be sustainable. And we really should be looking at ways of doing this that are a lot more energy efficient. So Shardus's goal is to build a system that's linearly scalable, which basically means that adding more nodes to the network should allow the network to get faster or be able to hold more capacity. We want to maximize the decentralization, which means that the nodes that you add to the network, they should increase, the decentralization of the network, meaning that the participants in the network are not all known to each other, and that you can participate in the network without having to make a very large investment. So those are kind of the things that you have to design into your system. And we also want to maximize the efficiency. To do that, you need to use consensus algorithms that are more energy efficient. So, those have been around since the 1970s. There's algorithms like, PBFT, but they require all the nodes to know about the other nodes in the network. And so they've been used in scenarios where, you have private, networks, but in public networks, that's been a challenge. And so if we want to, maximize the efficiency, we actually had to figure out how to get the best of both worlds, where you can have nodes know about the other nodes in the network to get more efficient consensus, but yet allow the network to be unbounded so that anybody can join the network. So what's the secret sauce behind Shardus that's kind of, make this work? So one of the key technologies is what we refer to as on-chain sharding, which basically means that rather than, having multiple chains, we're having just one chain, and within the chain, the nodes are sharded, and sharding effectively means to create multiple groups of nodes so that the work can be divided up among those nodes, so it increases parallelism. And that's a technology that's been used in the database world for many years, but it is a challenge to apply it in the blockchain world. And part of the challenge is because we're putting all the transactions into blocks in order to make the consensus more, what's the word, to try to make the consensus be more efficient. And so we're finding that, that's probably not the best way to do things. So another thing that Shardus does is it takes a blockless approach where the transactions are processed immediately. And so we're more of a distributed ledger as opposed to a blockchain. And we're using, algorithms that are more akin to a proof of network type consensus. So therefore, it's more energy efficient. And our systems are designed to auto-scale, which is another very important aspect that a lot of other chains have not really thought about this, but you don't necessarily just want a whole bunch of nodes to be able to just join your network if it doesn't need it. Your network should be able to decide and regulate how many nodes it wants in the network, right? Whenever we design things for companies, we don't just, throw a lot of hardware. We try to scale our systems so that we have just enough hardware to meet the demand. And so that's where, we're designing Shardus so that it can auto-scale and increase and decrease the number of nodes in the network so that, we're most efficiently using the nodes in the network. So the advantages that you get are, linear scaling. You get fast transaction settlement times. You'll also hear that referred to as fast finality. We have efficient consensus. We have an unbounded network size, meaning that anybody can join the network. The network can grow to handle, thousands, tens of thousands of nodes. There's no impact from other decentralized applications because a lot of networks like Ethereum Tron, Waves, all these networks are designed such that there's one platform and everybody is building a decentralized application on top of that platform. Shardus is just taking a completely different approach. We're saying, here's the software, go launch your own network. So you can compare it to something like, if you're familiar with web hosting, there was shared web hosting, where it's very cheap, but you're sharing that same computer with maybe 100 other websites, and if one of those websites gets really popular, it's going to impact your website. So that's the scenario that we have currently with networks like Ethereum. But over time, people don't want that. They want to get their own VPS. They want to have more control over having a guarantee that, hey, this hardware is going to be available to me. And so that's, with Shardus, we provide that. And we're designing it so that it's very easy to develop on and deploy, because we are not just building this for somebody else to use. We're building it because we want to use it ourselves to build, Getcoin and Globalville and Liberdis and other projects from it. So we're, very focused on making sure that we can build with this real easily and deploy those networks easily. So the use cases for networks that can handle these kind of, billions of daily active users, millions of transactions per second, we're not even kind of envisioning those scenarios right now because our networks are so slow. I mean, if we get 1,000 transactions per second, people are happy. But once we get to those kind of levels, it's just gonna open up your mind to think about, man, there's so much more that we can do with this, right? And so now you can start thinking about having things like a true global scale cryptocurrency, or a global scale decentralized identity networks where every individual in the world could be on that network. You could have global scale communication networks. You can create social networks like Reddits, Twitters, things like that. Countries can put their coins on it. Enterprises have lots of applications that need really high throughput, so they can start using these kind of things. And I know there's a lot of people that have ideas for building applications, but they just look at the technology that's out there and say it's not ready yet. So the team that we've put together that's working on this, the team that's leading this is myself, Andrew Foster, and Samir. We all have lots of industry experience in building back-end systems for big companies that handle millions of users on a daily basis in a production environment. I've worked at NASA, Yahoo, Zynga, also at a few startups and mobile gaming companies. Andrew's got a lot of experience in the gaming industry. He was on the team that built Halo Wars and Castleville, and those are projects that had millions and millions of users. And Samir's worked at Office Max, Chevron, Yahoo, Cisco. So between us, we have 60 plus years of industry experience building distributed systems for companies. And we also have other developers, some of whom are here today, like Amer. Derek couldn't make it. And also we have remote developers as well, but we work with them directly. We don't just outsource it through some company. They're directly interfacing with us. And we, like Samir said at the beginning, we like to impose these self-quarterly reporting on ourselves so that we can hold ourselves accountable to what we're trying to build, and also let the community know our progress. And we're focused on the execution of it. We structured the project in a way that we don't have to think that much about the funding. And so I'll get into that now. So basically, how do you support a project like this? So in the US, it's a little bit difficult because there isn't like really clear guidance on in this space. And the SEC is basically saying like everything is a security, and the ICO out there is basically a security. So one of the things that we're doing differently is that we have a token out there, but we are not doing an ICO, and we're not selling the token to the public, so the project never sells the token. Instead, we use our tokens to give it to our developers, people that contribute code, do bounties, or do anything else directly for the project can earn the tokens. And the tokens that you've earned, you're free to sell it to your friends and families, or there's online decentralized exchanges and things like that, so you can sell it through that as well. And so one of the things that we didn't have to worry about, it saved us a lot of time and resources in getting started. Typically, if you want to do an ICO, these projects spend like 6 months and spend anywhere from 500,000 to $2 million just in the legal fees to get set up to do ICOs and things like that. And we feel that this helps with better alignment of the incentives to ensure the success of the project. So we're we're receiving the tokens. We want to work hard to make the value of those tokens go up, so it'll benefit us in the long run. The amount of tokens that are out there, we issue the tokens using a nominal 10 cent per token value. So like if somebody does $1,000 worth of work on Shardus, we'll give them 10,000 tokens. And so while the project is being built, the token supply is going to increase. And currently it's at 13 million tokens. And we have a wiki on our website that you can look at to see exactly how many tokens are in circulation. And also we have a page in there that shows you like what you need to do to go look at the Ethereum Explorer to know exactly how many tokens are out there. So you can validate and check that yourself. And we expect that by the time the project is completed, there will be about 40 million tokens in circulation. And at that point, we're not going to be issuing any more Shardus tokens. But the Libertas project, which is getting created, will allow the future development of Shardus. The Libertas project is going to be structured so that it has a development fund. If you guys are familiar with like Dash Network, they have a fund which is used to support the development of the Dash coin. So that's an interesting idea, and so we want to adopt that into the Libertas network, and you'll be able to use coins that go into the development fund to support the Libertas software as well as the Shardus software. And at that point, the amount of Shardus tokens, which will always stay on the Ethereum network, will start to decrease as they get used for licensing. And so that brings me to the next point of, what are these tokens used for? So the Shardus tokens are needed for software licensing. So if you're creating a private network using the Shardus software, you'll need to obtain a license token by buying Shardus tokens and sending them to our smart contract, which has a purchase license function on it. And that function will actually burn the tokens that you sent it and issue you a license token. And since that's happening on the Ethereum network, it's publicly available. Anybody can go see who's obtained a license or not. For public projects where everybody might have access to it, those projects typically need to have a coin for the ecosystem of that project. And the way the licensing works there is that those projects will need to give at least 1% of their coins back to the Shardus token holders. So without losing any of your Shardus tokens or having to sell them, you will be receiving coins on new networks that are being created with the Shardus software. So that's the model that we're taking. And I think this is a very new approach to doing software development, because in the past you only had, two models. One is a company gets set up, it hires developers, and then pays them to build the software. But the company owns the software. The developers just provided services. Or you have the other model, which is the open source model, where a bunch of people get together and build some software and just make it open source and available, because they have no way to decide who owns how much of that software, right? So it's like, yeah, you can come and contribute, but this is an open source project, and you get like kudos for having worked on an open source software project, and it might look good on your resume, so that's the kind of benefit you gain. But with tokens now, you can have a new hybrid model where people that work on a project can receive the tokens, and once the software is completed, licensing can be applied to that software just like you would with the company, and the tokens that were given are going to be used for the licensing. And so it creates a new model that wasn't possible before we had this concept of tokens. So the roadmap for Shardus, overall, this is a high-level picture of where we started and where we're going. We've already demonstrated a consensus algorithm working, and then after that we demonstrated a distributed ledger where nodes are able to connect up, join the network, synchronize, do consensus on the transactions that are being thrown at the network. But it was not a sharded network, so it was every node held the complete state. Now what we're working on is sharding that network so that different nodes would be holding different amounts of data, and that we're going to be demonstrating a little bit of that, but it's not complete yet to the level where we can just launch a network and it's sharded, but we can start up a network with a blank state and still inject transactions into it and show that those transactions are getting applied and getting distributed appropriately. Next quarter, what we'll be doing is adding more extra support that's needed for that sharded network. So when a new node comes in and joins the network, well, it can't just ask any node to give it the data. It has to know the appropriate nodes to ask to synchronize. If nodes lose some data, how do they go and get it from other nodes? You can't just ask anybody. You have to understand how the network is sharded. So those kind of things are what we're going to be adding next quarter. And once that's done, we'll be able to demonstrate a sharded network for you. So definitely don't miss the next quarterly update, because that's going to be something exciting to see. And then once that's completed, we're going to start focusing on building out the Liberdis network. And we figure that's probably going to take about 3 quarters to get that built, and then by end of Q2 2020, we should be launching the Liberdis network. So this quarter, some of the things that we did, we've added what we refer to as lost node detection to the enterprise server. essentially, in our network, every node has to know about every other node that's in the network. And so if some nodes just drop out of the network, well, the network has to, every node in the network has to update its table of what nodes are in the network, but you just can't do that. There has to be consensus among those nodes so that they stay synchronized. So that was a trickier problem than we originally thought it would be. So it's taken us a couple quarters to get that right, but we've got that working now. And then we've been working a lot on the global server. The global server is the one that has the sharded state. So we've got the transaction routing working, the sharding of the state and transactions, the consensus and the cross-shard communication, all of that is working. The partition repair is working, but there's more to be done with that, which we're going to be doing next quarter. One other thing that we wanted to do this quarter was, add a archive server, but we weren't able to make as much progress on that as we wanted to. And so that's something that I think we'll be pushing off to next quarter. So some other things that we did. So that was, on the technical side, those are the things that, we've been working on. But, there's the other side, which is, increasing the awareness of Shardus. And also, companies looking at Shardus and evaluating it. So people have been hearing about Shardus, and word is getting around. And we've had, two companies approach us. One is the Temple Group, Dan and James. They're here with us today. So they're evaluating the Shardus software to see if it can, fit their needs. Another startup called VeryPro. They've also signed an NDA with us to evaluate the Shardus software. So the enterprise, server is in a state that, we can allow companies to evaluate it, and, we can work with them to see if it can be applied. And while they're doing that, we'll be working on the global server, which is going to have sharding, and the interface between the enterprise server and the global server, between the application layer and the Shardus layer, is exactly the same. And so once the global server is ready, you're going to get sharding for free. So you can build now using the enterprise server, and then you can use that same application layer and move it over onto a global server, and the APIs are exactly the same, so you don't even know that, underneath there's sharding going on. So that's one of the awesome benefits of building on Shardus. We're also working with MLG blockchain for marketing. In the previous quarter, I mentioned that we were working with Global Blockchain Network, which is a company based here out of Dallas, but they got acquired by MLG blockchain. So now we're working with MLG blockchain on the marketing. We've also been given some presentations about Shardus. So we actually were invited to do a presentation for Tim Draper's Draper University. They were interested in universal basic income, and because we intend to build, Getcoin and Globalville, which are based on the concept of universal basic income, we were invited to do a presentation of, what we're doing. And also we did a presentation at the ICNA convention in Washington, D.C. this year. So that was pretty interesting. Also, we've done presentation at the UTD blockchain conference. And some of the people that organized it are here with us today. And also, more recently, we did a presentation at the Dallas Blockchain Capital Summit, which brought together companies in the Dallas area that are working on blockchain and VCs and investors that are interested in this space. And we also got listed on CoinGecko, which is a service that lists different projects in the space. So one of the challenges for us has been that, you know, we're trying to stay focused on just like if we do get, well, I mean, the people that have the Shardus tokens can list it anywhere they want, but the project itself is not interested in listing the token on centralized networks. I mean, so it's much easier to get listed on decentralized networks. And so those decentralized networks are not covered by a lot of the coin listing services. And so, you know, which makes it a little bit harder for people to become aware of Shardus because it's not listed on those. But that's starting to change. You know, the decentralized networks are gaining more and more prominence, and more people are using them. And so CoinGecko recently started covering Uniswap, and so so now, you know, you can find Shardus on CoinGecko. Okay, so the other thing that we did this quarter is we built an interface to the Uniswap system. So the Ethereum Foundation put out a grant to have these contracts created on the Ethereum network called Uniswap. Basically what those contracts do is allow any ERC20 token to be paired with Ethereum, and once one of those contracts is created, anybody can go and add liquidity to those contracts. And then once liquidity is sitting in those contracts, other people can, you know, put in one, you know, token and take out Ethereum, or you could put in Ethereum and take out a token, and those contracts are linked with Ethereum being the hub. And so you can even just go from token to token. So if you have, you know, say a token like DAI, and you want to get, you know, the Shardus token, with just a seamless hop, you can go from DAI to Shardus token. So those contracts are sitting out there. They're not that well known about, and the interface to use those has not been that good. So as a way to help, you know, people find these contracts and these tokens, we've built a better interface to it, and it, you know, will definitely help increase the usage of the Uniswap contracts, but it'll also help bring more awareness to the Shardus project, because the uniswapdex.com site, you know, has mentioned that, you know, this interface is built by the Shardus team with the link back to the Shardus project. And currently the Uniswap contracts, even with the not so great interface that they have, are getting, you know, like $2 million worth of daily volume being transacted on them. And, you know, we're sure that's definitely going to grow over time, and especially with the better interface. And I think that's going to help some of the other bigger listing services like CoinMarketCap start to recognize Uniswap, because once the volumes grow, then they can't ignore it anymore. And interestingly, back in 2017, there was a project called Bancor that did something very similar, and they raised like $150 million to do that. And just, you know, so now, like, we built that interface for free. Okay, so our Q3 plan is to focus on the global server. So one thing that we need to do is get the archive server finished up. We have to add the ability for nodes to join a sharded network and be able to synchronize. We have to add the ability for nodes that have maybe missed some data to be able to repair their data in a sharded network. So there's lots of little, things that you need to take care of before you can actually, have a full-blown network that's sharded and works properly. And also we need to improve our visualization tool that we use to monitor the network. I think, some of you may have seen that tool in the past, and you'll see it again with the demo that we're doing. But it's going to be a little bit more of a challenge to show networks that have a lot more nodes in it, and also where the network is sharded. But we'll be making those changes. So without further ado, we want to show you, like if you got access to the Shardus software, what would it be like? What would your experience be like trying to, build your own little network to do something simple like a little coin and, deploy that? And so Amr is going to show you that.
Hello, everybody. So my name is Amir. And today, I'm going to show you how you can use our tools to build a decentralized application with the Shardus framework. Now, you could have a great framework, but if your tool set around building with it is not too great, not too many people are going to build with it. So while making this tool set, we try to keep in mind that ease of use is somewhat key to let people build with it. All right, so the core of building something with the Shardus framework, well, the Shardus framework provides you this thing that takes care of consensus, takes care of peer-to-peer communication, all those really hard problems that, like, when you as a developer want to build an application on it, you just want to worry about the business logic and not have to go into that kind of stuff, right? So we built this command line tool that helps you get started with the Shardus framework, which lets you create a project and gives you scaffolding to quickly test changes, debug those changes, and kind of get into that development flow really easily. So if I have this installed on my computer, if you just type the Shardus command, here's what it is. It's the Shardus CLI tool. And this tool gives you the option to create a project from completely like blank slate, or to create a project from a pre-existing template. So for today's demo, I'll create a project from a coin application template, and we'll make some changes to that and see how it goes. My app. And to get the template, you just go to the official Shardus GitLab page, open up the templates page, copy the URL that gives you into your command line. And there it goes, it's setting up your project. So what this will do is it'll run for a couple minutes and set up the scripts that you need to iterate on the code. And this will take a while to complete, so for the sake of time, I have one kind of pre-made. We'll go into that guy. And as you can see on the left-hand side, this gives you an index.js and a client.js. This index.js is going to be the main business logic of your server. It's going to contain all of the functions that you need to implement in order to have your business logic built on top of the Shardus framework. And what this will do is let you run these servers that have your application on it, but you want to be able to interact with those servers too, so we've built a client. This client comes with the template to let you interact with whatever you built. So let's give it a shot. Let's run it and see what happens, yeah? So what I just ran there was one of the scaffolding scripts that we provided to help you do this quickly. What this does is it starts up a local instance of a node, and you can see that coming up if you go to this URL here. We include a nice visualization tool as well for you to see very quickly your nodes standing up. So you can see our single instance is green, it's ready to go. Let's interact with it. So like I said before, we have a client that comes with the template that lets you interact with the server. I just started that up. It gives you a couple commands. Since this is the template for a coin application, you want to be able to create wallets, you want to be able to create tokens, you want to be able to transfer those tokens, right? So let's see if that works. Create test wallet. All right, tokens create 10. So this will send an actual transaction out to this node, and that little dot down there shows you the internal state of the node, like all the data that he's holding. So once we create tokens for that wallet, that should change. The color of that dot should change. So let's run that. Alrighty, so the transaction seems to have been sent. And now we're waiting for that. Oh, there it goes. So it changed from blue to red, which means the state has now been updated. You now have 10 coins on this network. So let's query that. Oops. Test wallet. As you can see, my balance is now 10. Now if I create another wallet, test wallet 2, and then transfer tokens to that wallet, and I query it again, you should be able to see that, some of the tokens that I sent are showing up in the other wallet. So let's do this transfer. All right, tokens transfer. Let's do 3 from test wallet to test wallet 2. All right, so that transaction has been sent. Now this dot will change, letting us know that the server has accepted that transaction. There it goes. And we'll run our query. Test wallet. Actually, I think if you just run query, yeah, there we go. As you can see, the balance of our first wallet is now 7. Balance of the second wallet is now 3. And that's all it took. This all comes pre-made. As soon as you set up a project, you get this from the get-go. So that's all good and fine. I've demoed how you can take a template, create a project from a template, and now interact with that template, see if that's all working. But the real thing is you want to make changes. You want to make this template do what you want it to do. You don't just want it to be a generic coin application, right? So where those changes are going to be made is inside this index.js file that I mentioned earlier, which holds the business logic for your application. And that business logic is actually all in here. These functions that you see, like validate transaction, apply, and such, they're actually defining the API from which your application will talk to the Shardus framework. And the great thing is, once you've implemented these functions for the enterprise server, you're going to get, this will work the same way on the global server without any changes, but you'll get sharding as well. Because I'm sure Omar has made clear that the enterprise server is all the nodes have all the data, and the global server, they implements sharding, so not everyone has to hold all the data. It's actually linearly scalable. So you don't have to make any changes once you've built this application on the enterprise server to make it work on the global server. So let's look at the logic a little bit. As you can see from before, we had a create transaction and a transfer transaction, right? That's all it took to make those. It's just 2 little parts of the code here where we define when you create, you add some balance to an account, and when you transfer, you subtract from one account and you add it to the other. And that's all it takes. So to give you an idea of how you can change this to show something else, I'm not going to add another transaction type, but I'll add an endpoint to the server. So since this is running locally on my computer, I can actually visit it at the port that it says over here, 9001. It's going to be hard to show because that disappears, but 9001. Oops. Info. There must be something up with the firewall, so it's not letting me connect to it locally. But anywho, we could make a change to this, and with the scripts that we provide in the template, what you would do is you'd stop the server that's running, and that's running right now. This is the stop process. You'd clean the files that were created from the last run. You'd make your changes up here, and then you'd run npm start again, and that would bring up another instance of that node that you can now play with and see if your changes are working. So since everything is stopped right now, this monitor service is now stopped too. It's all, you're not going to be able to connect to it. So great, we've just iterated on a single version of your software that runs locally. But if you want to make an actual decentralized network, that's not the only thing you want to do. You want to also be able to run a network of those nodes and see if they work together properly, right? Before, like if you're building on the Ethereum network, you want to be able to test with like a local Ethereum network to see if your contract is good before you put it out into the public, right? So the Shardus tools also provide that ability to test and like run a local network before you send it out to the global, general public. So to do that, what we'll do is, again, back to the Shardus command line tool, but this time we'll do Shardus network create. And what this will do is that it creates 10 local instances. It gives you a bunch of options that you can configure, but by default, it'll create 10 local instances of the code that you just made and run them on your local computer and see if they like interact with each other the right way. So let's start this network. Oops. I have to cd into that instances folders first. And there we go. We can watch them coming up. And if we go to our network monitor from before, there we go. There they are. There's our 10 instances, and they're going to start joining the network. So as you can see, there are different colors here. When they're gray, that means that they've just sent a join request into the network. When they're yellow, it means that they're syncing up their data to all the data that's already there. And then when they turn green and show those 3 dots, that means they're ready to go. And all that stuff is like kind of part of the lower details of consensus and those things that, like, when you're developing an application, you don't want to have to worry about. They come out of the box for you. You didn't have to make any code changes to make that happen. So this network's going to come up. It's going to take a couple seconds for that. So while these nodes are coming up, you can actually view their logs and whatnot as well. So if you're, like, from a developer's point of view, being able to see that is really important. So you can look at things like, what's the console output of these nodes? Did something happen while this guy was standing up? We're like, oh no, it's not working, or something like that. So help you catch errors kind of like early without having to like do in-depth debugging. As you can see, we got the output. But yeah, so these guys are now all syncing up. And once they turn green, we can run some transactions through them, see how they're able to keep up with their state and everything together. In fact, we could probably run some transactions through it right now before all of them have synced up, and the ones who do sync up should get that same state. So let's go ahead and create some coins. So tokens create, let's see, 10 for test wallet. And since this guy is the one that the transaction went to, his state should change first. And the other guy's state changed with that. See, it went from blue to black, that dot on the bottom. Tokens transfer, let's do one from test wallet to test wallet 2. And this little dot down here should change if all of them are able to sync up on that transaction. And there it goes. Yep, that first guy did, and then all the other ones. Let's do that a couple times. You can see transactions coming in, spreading throughout the network, and the states being updated. So that's an example of running a local network of nodes with your application on it. So now that that's done, we've iterated on a single instance of our application. We've made a local network from that instance. Now we want to be able to send this into the global world, like be able to make a global network with these instances. So what we've designed is an internal tool to let you, once you have this code ready, deploy it to an Amazon AWS cloud and see the same code that you just worked on running like in however many regions throughout the world with however many instances communicating with each other and doing what they need to do. So this takes a little bit of time to set up, so I've kind of pre-done this, but what you would do is you'd start this command line tool, you'd tell it to create a demo network and tell it how many regions you want to put nodes in and how many nodes per region, and you let that run. In like about 5 to 10 minutes, it lets you know that it's all ready to go, and it gives you a URL. And that URL is the URL from before that lets us monitor these nodes. So we're going to put that into a web browser and see this happening. Oops. Got to get the port. There we go. And these nodes, so before they were running on my local computer, these ones are actually running on the internet. These ones are out there and you can interact with them. Like, I think we have like 3 in Tokyo, 3 in Canada, 3 in however many regions we define there. And we made it really simple for you with this tool to deploy your code that you've developed locally into a global network. So with that, I think I've covered all of the steps of creating a decentralized application. We have a little guide here from the template that we've used where you iterate on a single node, you test a network of nodes, and then you put that into the global network. So I think that concludes my talk. Thanks, guys. Yeah. All right.
All right, so you had a chance to see now, you know, like if you're actually wanted to build something with Shardus, it's a pretty easy process. You know, we use Node.js because a lot of, you know, developers out there are very familiar with it. You know, that JavaScript is the #1 most used language out there, and Node.js is really just JavaScript on the server side. And it's, you know, pretty performant as well, easy to develop in. And so you can very easily now, you know, create your networks, launch them locally, then deploy them on AWS. And with that, the next thing we want to show you now is, you know, some of the exciting stuff that we're doing with the sharding. So this is probably, you know, one of the first few demonstrations that you're going to see of blockchains, you know, showing sharding working. So for that, I'd like to call up Andrew, and he'll do a quick demo of that.
All right, so time to show off some good stuff here. So this is a demo that'll update you on our global server, and like Omar said, we've got state and transaction sharding working, and early testing has been going great with it, and let's do a live demo. So I'm going to start a network of 15 nodes and bring up something to take a look at that. There we go. So here are the nodes coming online. They kind of join in phases. And this is our global server. So it's the version where nodes don't have to handle all of the data and all of the transactions anymore. That workload is spread between different nodes in the network. And that's using sharding of state and transactions, and that's a pretty important part of what we're doing here. I mean, it's kind of in the namesake of our association. And things do get a little more complicated, at least for us, when we have a sharded network, because since the data is spread out and you have to make sure the data is in the right place at the right time if you want to be able to execute transactions on that. And so as soon as these join up, I'll start sending them some transactions, and we'll take a look at that. This visualization is what we've used in enterprise, and it served us well for being able to like quickly take a look and debug things, but there's definitely some exciting ideas we have to make like a newer generation of visualization that we'll need to look at sharded networks, mainly because we'll start running with like so many more nodes, like hundreds or thousands. We'll want a more efficient way to view them. And also, this one, the bottom circles here, I think we've gone over it in some presentations. So we got the top two circles. It's like our node list and our sort of a cycle marker. And then the bottom one is that our data is our color representing a hash of our data. And so no data has been sent to any of these like freshly started nodes yet. So they all show the same color. But in a second here, I'm going to send some transactions to them. I'm not sending them transaction right now because one of the things with global server that we're going to do next quarter is the data synchronization. So that's like when you have nodes constantly joining and leaving your network, you have to have a good trustless way to share that data to the correct nodes. And they're up, so I'm going to hop over here. And all right. So I'm going to give coins to 10 accounts here. Give each account's going to get like 5 transactions of 10 coins going to it, just to kind of get some money and some accounts into the system. And so what we're looking at here, we've got, our data is all different colors now, and that would be like a disaster if we were, in an environment where every node was trying to have the same data locally. But right now, since we're using this enterprise tool to view into a global server, this is exactly what we want to see. So there are some clusters where like, all right, these couple of nodes have the same data, and then a few over here. And what you're seeing there is that because our network is virtually sharded, there's no requirement that every node like stores exactly the same data as some other node. It's just that nodes kind of individually like have calculations to know what type of coverage they need. It just so happens that these 3 here are covering the exact same data, and that's because we're using a pretty small number of nodes. Like when you grow to like hundreds or thousands, it's like less likely. Also, what you don't see is if we were using fixed shards, in that case, you would see like, there's exactly 4 pink ones and 4 orange ones and 4 green ones. And that's what it would look like if our shards were like very rigid. But they're not rigid, because if they are rigid, then it's difficult to scale. And part of what we do with our network is be able to look at the load and allow additional nodes to join the network if it's needed. Since Omar kind of talked about efficiency as what kind of wins in the end, that's important. So our networks basically grow when the capacity is needed. And of course, as like an application developer, you can adjust parameters on that. So let's see, I'm gonna go back over here and take a look at some of what our accounts have. Let's see. So this is going to list the wallets that I've created in this client here and what their values are. And let me make that a little more readable. Okay, so, A0's got 50 tokens, and A1, A6, and A7 have 0. I guess A1 and A6 and A7 are probably pretty mad right now because their money's not showing up in their account. And actually what you're seeing is this was an older endpoint that simply asks just one random node in our network, hey, what's the value for all of the local accounts? Well, our local nodes no longer carry all of the data. So if you hit this old kind of debug endpoint, this is exactly what you're going to get. We're not going to see the full picture of the data. So there's this wonderful list2 command that hits a different endpoint, and in the application, it kind of receives that endpoint, and as an app developer, you can call a real easy function into our API that's like get local or remote data. And so if the data's local, it's very quick to just then know to hit the database and return it. But if it's remote, it also can do the math it needs to figure out a good person to ask for the data. So if I do that, now we see everybody's got what they should. And those commands I ran were just like taking one account at a time and giving them some coins. And so that's pretty simple. It's actually maybe like too simple. And we've had in our coin app for a while like a transfer command that's like, okay, that's the classic. Let's take some coins and move it from one user to another. Even that's like a little bit simplistic, and we didn't want to like forget to design for the general case, so we needed another command that would stress the system a little bit more functionally. And so came up with a command called distribution. And what this is going to do is take one account, A0, and give one token that I've specified to any number of other accounts. And so this transaction is actually involving many different accounts in the network. And the reason it's going to, I'll just add a bunch. A0 is feeling really generous today. Yeah, okay, so there's A0 is going to give one token to 7 accounts. And if I tab back over to the network monitor, boop. And so these colors are going to kind of change again. But still at a glance, we can't really tell like, oh, you know, is the data consistent? Is it functioning properly? We did kind of see that like when there was a group of colors, they changed to another color. So that consistency is like a good sign, but that's not really what you want when you're trying to iterate quickly and validate that things are working correctly. So until we have our like super next generation visualizing tool, what we have to validate things is basically like we can collect logs and do analysis on them. We've had some like log analysis for a while to make sure that like, oh, like for a single gossip transaction that's propagating through the network, can we go back and like do forensics and make sure it got everywhere it needed to be? Oops. But we needed some additional stuff to take a look at, you know, is this new sharding technology that we're bringing online working like it's supposed to be? So I'm going to open this over here in Sublime, and whoa. Maybe I need to refresh that. I think I might have opened that file when it was still in the process of writing. So I apologize for like throwing such a like wall of text log at you guys, but I think it's worth like a little like quick mention. What this is representing is like the different partitions in our network. There's 15 nodes and 15 partitions. That's like different kind of clusters of data, and together those like kind of like are related to the sharding aspect. And what we're wanting to see in this log is that for a given partition, like partition 3 here, what you want is most of the nodes in your network to have no opinion of that data whatsoever. So 12 nodes have voted that they see no data in partition number 3. We've got 3 nodes that have voted that they have seen some data, and so that's exactly 2 different versions of the story. One story is there's no data, the other story is here's the data. And then the data that we see is basically going to be an array of accounts and their IDs and their hashes and their balances. So like, oh yeah, that one has 51 tokens. Oh yeah, I forgot to actually wallets list 2. Yeah, I should have run this. So here's A0. It's now 7 tokens poor, and then A1 through A7 I'll have like an extra token now. And basically we're kind of seeing this in the logs, and what we're seeing is good. There's like a little summary that says all tests are passed, and that's like basically it's looking for that, you know, the right nodes have the right data, and it's, you know, asking the consensus nodes in the network what they see. And then we also got, since we also don't have like beautiful visualization yet on like, oh, here's some beautiful picture of how these like virtual partitions are laid out. Instead, I've got this like lo-fi ASCII art for you guys today. I won't go into details, but it's basically looking at like who's home nodes and consensus and edge nodes, and so stuff that's useful for when you're developing a sharded system. Let's see, so the stuff that was going on in that distribution transaction was that to have a transaction that can involve that many accounts, it had to make sure that the data was at the correct data, like the correct version of the data for every account was in the right place at the right time. And so this is something that has to happen in a live network when just transactions are flying all over the place. And that's kind of like a tricky task to pull off, but that's something that we're handling with our software. And the way that we've designed the application interface for people to build distributed apps on is that when you're writing code for this, it's not really going to be a concern. Like, you're not going to have to wonder like, okay, should I read this data from the database, or do I have to like wait for it to come over to me? And then when you're done with the transaction, and you've got to like save out these like 8 accounts that we influenced because 1 lost some tokens and 7 gained some tokens. You know, should I even try to save this, or does this data even exist on my machine? That gets pretty complicated. I mean, especially since it's not like this, each node has exactly 1 account. Some might have like 3 of them, and some 1, or however many. And so as complicated as that is, something kind of cool happened when we decided we needed this distribution function, and that it was incredibly easy to develop on the app side. And by app, we have our own like simple coin app that helps us to validate stuff. So this is the code for the distribution function. There's like, and I didn't even, I added the distribution command to our simple coin, and it took 5 minutes. And I didn't even like refactor it to show it to you guys. So there's some stuff to like make sure we have accounts that I can probably like pull out of that. And actually all that really matters is that we're updating some timestamps on our source account and then just looping through our target accounts. And within that, all that really matters is that our source account is subtracting the amount from its balance, and a target account is adding the amount to its balance. And it's just a very trivial loop. So the reason this code can execute is because all of the data is momentarily local to this function. So your business logic can just do your business logic and not worry that these accounts don't normally exist on this server that is running the code. And that's pretty cool. Also, what you're not seeing in this function is you're not seeing like database reads and database writes. That's because our application interface changed a bit for global server, and we ported that back to the enterprise server. And basically, the reads and writes to your database are just a separate call. And Shardus, so you don't have to stress about when to call them. Shardus will say, hey, application, save this account's data. You know, hey, application, load this account's data. And so by decoupling those, your business logic can be very simple, and you're not stressing about, you know, juggling your data around yourself. It's just, it's loaded up, it's passed to this function, and then it can execute. Let's see. So, yeah, I think this is pretty exciting. I didn't think when I was writing just kind of a trivial piece of like 5-minute code that that's what I was going to be, you know, showing to an audience of people. But I think it's worthwhile to do because that's actually showing how it's easy to do something that's the entire picture of it's extremely complex, but for the application developer, it's pretty easy. Oh yeah, I guess one other thing I would mention, like when I'm talking about making this data local, we leave that up to the application developer to choose like how much data do you even need for your transaction. So if you're just getting an application up and running, you can, you know, send total account data around, and that's a great way to start. But if you're designing a system where the accounts are huge, right, you don't want to be sending like 30 megabyte, 100 megabyte accounts around all over the place all the time. So you can selectively be, when we ask you for the data, we say, hey, here's a transaction, here's the account, give us the data that you want to give us. And it's opaque to Shardus. Shardus doesn't even know or care about what your data is. We just ask you for it, and then we give it back to you when it's time for you to apply a transaction. And then when you've applied your transaction, we give it back to you to save to your database or however you want to save that. So pretty good stuff. All right. Thank you. I'm going to hand this back over to Omar.
All right, thank you very much, Andrew. So you saw, you know, basically sharding working. This is the start of the sharding. Hopefully next quarter, you don't want to miss it because we're going to have it completely integrated, and we'll be able to just launch a network of nodes, throw transactions at them. The network will be sharded, and it'll all work, and we'll hopefully demo like lots of transactions flying through the network. But underneath, there's some really crazy, complicated stuff happening, but that's all handled on the Shardus side. For the application developer, it just looks like, hey, I'm just, you know, I have all the data available to me. It's right there, you know, read and write locally, and it's taken care of. So what you just saw is like pretty amazing stuff. And there's not a lot of projects out there that have reached this level yet. If you're following this space, you probably know there's, I don't know, maybe about 10 projects or so that are working on creating sharded blockchains. A lot of them are kind of taking the approach that the blockchain is going to stay like a blockchain, and there's going to be different groups of nodes that, you know, have different chains that are, you know, basically sharded. It's a very different approach than what we're taking. We're basically saying, well, we'll treat it at the transaction level first, and we won't put everything in the blocks right away. But that doesn't mean that we don't have immutability. We still have immutability. We just do the blocking later. So if you're familiar with like how Stellar works, Stellar processes the transactions up front. There is consensus done on what transactions will go into the ledger, and then they create the ledger of accepted transactions rather than one node saying these are the transactions that are going to be part of the next ledger block. So I think a lot of, I don't know, if, a lot of projects are going to probably run into issues because they're doing the blocking first. But anyways, so that's, how, one of the things that makes Shardus different. And we're making pretty good progress with this. Our enterprise server is ready, and we're already, working with some startups to have them evaluated. We're, want to work with more. If you're like a blockchain consulting company, let us know. And we can, let you get access to the Shardus Enterprise server, and you can see if that could be used for some of your clients. And also, our token is there. The project doesn't sell the token, but if you can buy it from the people that have already earned the token as well. So that's a way to, support the project. And also, if you believe that, this has a lot of potential, then could help you out as well. And more information, go to the Shardus.com website, and you can always email me at omar@shardus.com. And feel free to stick around and network. We've brought together a lot of people together from the Dallas community that are into blockchain and cryptocurrencies. We'll be doing this every quarter, so it's like a great opportunity for a meetup.
How will you decide, or the network decide on how many shards, which node goes into which shard? And does that get adjusted, or how's that going to work?
Yeah, it's a good question. So the way it works in Shardus is every node has a node ID, and nodes that have node IDs that are close to each other tend to be like, having the same data. You can say that they're in the same shard, but we don't have like well-defined shard boundaries. It's virtual sharding. So nodes that have node IDs that are close to each other will tend to have a lot of data coverage. But you have to make sure that the nodes just can't pick their own node ID. So we have an algorithm where the nodes get to pick their public key, private key pair, but from the public key along with some random information that's generated by the network without any one node having any ability to create that data, that gets combined to create the node ID. So it's the public key of the node combined with some random data is what creates the node ID. And so therefore a node is not able to say, oh, let me put myself in this area and take over the network or something like that. So Amr?
Once a node is, I don't know, I guess I'm going to say assigned a shard, but that's not, I don't know if that's really accurate language, but once they're sharing data with another node, can that change? Can they start without dropping and leaving the network? Or do they just continue in that state where they're sharing that state with that set of nodes?
Yeah, no, that's another good question. So basically what happens is the address space of a node ID and the address space of the accounts are, kind of in the same space. So if your node ID, say, starts with 12, then all accounts that start with 12 would likely be the accounts that you're covering, right? So in a sense, the node, as long as it's part of the network, will be holding this, kind of similar data. As nodes come in and out, those boundaries might change a little bit, but the majority of the data that you're holding will be the same. And so that prevents like a lot of churn from nodes having to throw away data that they had and bring in new data. But we do have node rotation. So, every so often, the node that's been in the network the longest, those nodes will be removed from the network. New nodes will come in. They'll just randomly be, assigned some location in the network, and then they'll synchronize with the rest of the network. So that prevents, nodes from being able to just, have like too much control over the data that they're holding, right? So they shouldn't be able to do that.
So the crux or the approach is to be very random in assigning somebody to a shard or...
Yeah, actually, yeah, that's very critical, because otherwise, if nodes are able to pick, what their node ID is, then, you could have a bunch of nodes collude and all get, say like, your account started with the number 12. Well, this group of nodes could, try to assign themselves a node ID that starts with the number 12, and then now they're all colluding, and then they can, change the balance of your account or something like that.
Yep.
So, so effectively trying to take over any shard or set of data is as hard as trying to take over the whole network.
Yeah. So then, I assume that the transactions that will go across shards are slower. Is that true? Or how do you deal with that particular problem, or how is it dealt with, the cross-shard performance?
Yeah, so because we don't have like a different blockchain for each shard, we don't have to deal with like larger issues of, how do you, transfer information from one chain to another and so forth. Now, and so for example, in our case, because we're treating things at the transaction level first, and then grouping the transactions into, blocks, let's say, or partitions, we just have to deal with making sure the data that's needed to process that transaction is at the same place, so that these nodes can...
So if I wanted to give, if somebody submitted a transaction to me as a node, and my state says, well, that account doesn't have any money, I just first have to go and find out from some other, I have to go learn, or...
Yeah, there definitely needs to be like cross-shard communication. Now, sure, that adds a little bit of overhead to the transaction processing time, because, you don't have the data. So like, let's say, the transaction says, account A equals, B plus C. Well, you don't have account B and C, so that data has to be brought to your shard or to your node. So there's multiple ways that can be done. Either your node can go out to those other nodes, or if once this transaction is communicated, then those nodes know which other shards to send the data to. So you don't have to do a round trip, but nodes can take the data that they have and send it to other shards that need the data. And so, yeah, there's a little bit of overhead in communication, but we don't have that problem of like, having different blockchains being in like different shards, and then now, making sure that some transactions are already in a blockchain before you can actually use the state of those accounts and so forth. That actually adds more overhead.
Okay.
So,
Thanks.
sure.
So in the demo today with the distribution transaction, that was actually like very cross-sharding because it was hitting so many accounts. And what we're doing is as our transactions initially like gossiping through the network, we are preemptively and efficiently sending data exactly to where it needs to be. So there's not that wait. You don't like get a transaction and like, oh man, I got to go through a laundry list to like querying data and stuff. It's more like as this is propagating through the network, nodes are taking a look at the transaction mathematics and saying, all right, we have deterministic formulas to shoot data to the right place in a very efficient way. So. We gossip through a space called the transaction set, which is essentially like any node that would would be holding some of the data for any of the accounts in that transaction. So not the whole like entirety of our network. It's just who needs it. But yeah, as soon as that gossip's going through, then like nodes are preemptively sending the data out, and so it's pretty fast.
As far as the code that you showed here today, is that something that's going to be available on GitLabs, or is that something we would reach out to you for?
Yeah, so currently our software is closed source, but anybody that's interested in it can, work with us and sign an NDA, and then we can share the code with you. We do plan to make it open source, but not yet. So once we've built the Shardus software and then built the Liberdis network on top of that, and we launched the Liberdis main network, at that point, the code for Shardus and Liberdis will be open source.
And then a follow-up question is, as far as smart contract capabilities, how do you imagine that architecture looking? Do you want to do something similar to Solidity, where it's a standalone language, or maybe just use an existing one?
Yeah, so that's where, what Shardus is doing is very different than a lot of the other projects. A lot of the other projects that are doing sharding are just already like thinking, oh, we're going to build a final, system with this, and they're already like saying, okay, we're going to add a smart contracting language and, a VM and so forth. Well, Shardus is just focusing on just building the underlying technology, right? So you can think of Shardus as like the blockchain, whereas, then later on you add the virtual machine and the smart contract, then you have like Ethereum. So later on, we might do a project that we, talk about as ShardOS. And so that might be provide the virtual machine and the smart contract language. And there could be multiple projects that do, different VMs and different, smart contract languages, but using Shardus as the underlying framework for that, so.
Any more questions?
Hey, we are a blockchain consulting company. We are located in Plano, and we have a development center in India with 100 plus employees. In US, we have 30 employees, around 30 plus employees. So we are using Hyperledger whenever there is a solutioning. There are a lot of POC projects other clients are doing. So we are recommending Hyperledger, because IBM is our partner. And our CEO want to explore this platform. Let's say like I'm heading the R&D team or the roadmap. So I come up with a roadmap. Then we evaluate the platform. At the same time, it's my responsibility to train the team and go to the application team saying that, hey, go ahead, this platform is ready. I have 10 resources trained on that. You'll be good. Go ahead and try one of the project on this platform. So that is one of my duties, part of the duties. So, for that, I work with, other companies like, there will be a lot of programs. They train us, they give a lot of, pre-access, a lot of things. So whom should I contact, to continuously work with you guys, understand, more inside, and, continuously feed with a lot of information so that I can be your, mouth talk like inside my company. So I need a contact information so that I will continuously working with you guys and get more inside, and I will be the, inside my company, I will be your broadcast the information. So.
Yeah, that's really good to know. You can, reach out to us, and of course, we have limited resources right now that are all focused on actually doing the development. But as more companies start becoming interested in using Shardus and evaluating Shardus and, launching projects with Shardus, we're going to, get more resources that are more like in the consulting side, who understand the Shardus software, but then can go and work with clients and, help them get trained and, build their applications for Shardus. So But yeah, the first step is, reach out to us. Yeah, definitely. Yep.
Yeah, this email here is.
But yeah, I do.
Got it.
Amr?
You kind of just touched on one of the things that I'm curious about, is that it seems as if your team is doing an incredible job of being product focused, right? But one of the big things that y'all are going to have to address is how do you become the standardized blockchain or the system for, sending information across a network of nodes and validating it? So what's your strategy for adoption? Like pairing up with companies like his or startups like, in the ecosystem. What's your strategy to really make sure people use Shardus versus some of the other platforms that are trying to become the standard?
Well, that's a good question. And the way we kind of look at what's happening in this space right now is a lot like what happened in the database space back in the 1970s. If you remember, there was tons of companies that, popped up like mushrooms building databases, right? Fox Pro and, all kinds of tons of companies. But eventually, there was mergers and acquisitions and so forth, and the database industry became more consolidated and standardized. And the good ideas were incorporated into, newer products and so forth. And we're in the very early stages of blockchain. So I think it's too early for us to say how are we going to make sure that Shardus becomes the standard. We're just going to focus on trying to make the best technology possible. And, eventually it'll get incorporated or merged with other people that are interested in doing the same thing. And there's a lot of things to still be learned about how to build these blockchains. It's a lot of experimentation going on, a lot of ideas being tried out. So I hope no one of them becomes too dominant too early. Actually, that would actually set the industry back a little bit and not allow innovation. But yeah, I think our key to differentiating ourselves is one, make our platform be super easy, the Shardus framework be super easy to develop with and to deploy. That's one of the reasons why we chose Node.js. That's a language that a lot of people know. We could have said, oh, let's do it in C or Go or whatever, but the people that know those languages are a lot less, more expensive to hire. And so that's going to help us grow faster because we're using a language that a lot more people already know. So that's one of the things that's going to help it grow faster. And the tool sets that we're building, you saw how easy it is to create this network and launch it. If you've worked with Hyperledger, you know how much time you're going to spend a week trying to just get all your configuration and all this set up properly to do what we just did here in 10 minutes, right? So that's also going to help a lot, So focusing on making it easy for the developers, and then if the developers like it, well, they'll push it to the applications. So that's our approach.
Thank you so much.
Oh yeah, okay, Andrew, go ahead.
Yeah, and some of what will factor into which product comes out on top is going to be just the strategy that the different projects have chosen. And so, you see a lot of people doing stuff with smart contracts, which are a great solution for certain sets of problems, but we're actually kind of one step lower level than that. So maybe 5 different groups could put their own smart contract platform on top of Shardus if they wanted to. So, and maybe that could be a successful thing, but yeah, a lot of our design decisions are not limiting what will be the next future killer DApp out there, because it's such a new space. We don't really know what's going to be like this huge thing in a few years. And so starting with something that you can actually like code with in JavaScript and add endpoints and interact with other, things and give control to the application developers, along with the efficiency that we're providing is hopefully like a really good foundation for someone to build some innovative thing we've never thought of yet.
Okay. Any more questions? Yeah, go ahead.
With your licensing model, I'm still having a hard time understanding the licensing model, quite frankly. But are you having people understand it, the ones that are in this space, and discussing how you're licensing it, coins, and then going in a public and a private section?
Yeah, okay. Well, people that are kind of familiar with this space and, tokenization are more able to comprehend how this licensing works. But it is a new concept, and, for somebody that is not even familiar with, the whole concept of tokenization, that it's like you got to jump 2 levels, right? First, you got to understand what tokenization is and how tokenization can be used to create some kind of an ecosystem. And then in our case, you got to understand how that's being used for licensing, right? So just to give you like a simple example, let's say you wanted to make a dating service and you want to do it in a decentralized way. So you would create a token for your service, which, like if somebody wants to send a message to somebody else, they might need to spend some of those tokens in order to get that message sent to the other person, right? Now, the people that are running servers to provide that platform in a decentralized way, those people might receive tokens for providing that infrastructure. The people who created the original software for those nodes, they might hold some of the tokens, and they benefit by holding those tokens as the value of those tokens increases. So there's this new way of thinking about, how business is done actually in some ways, to understand how, things can be decentralized and yet, different parties that contribute to making that overall decentralized system benefit, right? So you have the people that developed the software, okay, so in the past you'd have like one company say like, okay, we're going to hire, coders to build, Match.com, and then they also provide the servers to run the infrastructure, and then they become the middleman and take cuts on people, getting subscriptions or paying, pay per message or whatever. And so this new model has lots of different entities working together, right? So there's one person that might create the code and other people that provide the infrastructure which the code runs on.
But wouldn't it depend, like a lot of the people that are going to benefit, they would need liquidity, wouldn't they? I mean, they can't wait, a lot of people will not be able to wait for.
Yeah, so if you build a system like that, and now your system is saying, well, instead of paying us with a credit card, you're going to pay us with the tokens, and the guys that are running the software to providing the infrastructure, they're receiving these tokens and they can sell the tokens to you. How does somebody that wants to use the platform get those tokens and use them at the appropriate time? Well, that's the other interesting thing about this whole space, is that because the transaction costs of moving these tokens around is so low, it's not possible for you to hold whatever coin or token that you want to hold and seamlessly do a conversion to the tokens that the platform wants. So for example, you might be holding Bitcoin, but the platform says you need to pay in Match coin. So other providers can provide this service to do an instant conversion for you, right?
And could I also just do a fiat currency as well to Bitcoin and then just
Yeah,
go all
there's,
the way
I
through?
mean, of course, there's going to be people that provide those on and off ramp between fiat and cryptocurrencies as well. But usually going straight from fiat to a particular token is probably harder. You're probably going to find it easier to go like fiat to some stable coin that's a cryptocurrency, and then that coin to whatever the platform wants. So there's, this is a whole new way of building things.
Very interesting. Thank
yeah.
you.
Any more questions?
So thank you all for coming, and hope you'll be here next quarter.